Have you ever held a piece of gold in your hand and wondered, how did this tiny, shiny metal actually reach this level of perfection? We see it in jewelry stores, in banks, and even in global financial markets. But behind that sparkle is a story of fire, chemistry, and some of the most dangerous industrial processes in the world. Today, on Food Factory, we're taking you deep inside the hidden journey of gold. From rough rock pulled out of the earth to the stunning bars and coins that reach over 99% purity. And trust me, the process is not as simple as melting and pouring. It's a mix of mining risks, toxic chemicals, and some pretty clever science. So let's start at the very beginning. The hunt for gold itself. The search for gold, where it all begins. Gold is considered one of the rarest natural elements. To give you perspective, if we were to gather all the gold ever mined in human history, it could fit into a cube just about 72 feet on each side. That's it. But finding gold isn't like picking pebbles from a river. It's buried deep within the earth, trapped inside rocks, or hidden in sediments. And extracting it is an enormous challenge. Mining companies use three major techniques to get their hands on gold. Open pit mining. Imagine a massive crater carved into the earth with giant trucks and machines moving like ants. That's open pit mining. It's cost-effective and safer than digging deep shafts. But the downside? It destroys huge areas of land and can disrupt entire ecosystems. Underground mining. Here, miners carve tunnels through mountains and deep into the earth. It's risky, claustrophobic, and requires advanced safety systems. Roof bolters, sprayed concrete, and even drones are now used to inspect dangerous areas. Still, one wrong move and collapses can happen. Placer mining. If you've seen old Western movies with gold prospectors using pans and rivers, this is that method. It's the oldest and simplest way of separating gold from sand and gravel using water. While small-scale, it's still practiced in certain regions today. Regardless of the method, raw gold doesn't come out glittering. It usually exists as tiny flecks stuck inside stone or as impurities mixed with other metals. And that's just the beginning of its long transformation. Crushing and grinding, preparing the ore. Once ore is extracted, it heads to processing plants. The first step is size reduction. Huge crushers and mills grind the rocks into fine powder. Why? Because increasing the surface area makes it easier for the gold to be separated in later stages. Without this, much of the metal would remain trapped in stone forever. Think of it like cracking open a walnut. If you don't break the shell properly, you'll never get the full nut inside. Extracting gold. Dangerous chemistry. Now comes the controversial stage, separating gold from waste rock. One of the most common techniques is called the cyanide leach process. Crushed ore is soaked in a solution containing cyanide, a deadly poison. This chemical dissolves gold, allowing it to separate from the rest of the material. But here's the catch. Cyanide spills can poison rivers, soil, and entire ecosystems. That's why many countries have placed strict controls, and researchers are constantly looking for safer alternatives. Another option is gravity separation. Since gold is heavier than most surrounding minerals, powerful centrifuges and shaking tables can pull the precious metal away naturally, without chemicals. Still, these methods only produce semi-pure gold, often between 60 to 90% purity. That's not good enough for markets or jewelers. So, the journey continues. Smelting. Fire meets metal. After extraction, the ore is smelted. Workers heat the material to nearly 2,000 degrees, 1,093 degrees C. At this extreme temperature, impurities rise to the surface as slag, while heavier molten gold sinks to the bottom. It's a dangerous job. Workers wear heavy suits, helmets, and gloves to protect themselves from splashes of molten metal. One mistake, and the burns can be fatal. The result? Bars of impure gold, often called doré bars, that still contain unwanted materials like silver, copper, and other trace elements. But now, we're getting closer to purity. Refining. From 90% to 99.9%. Here's where science takes over. To achieve near-perfect gold, refiners rely on two famous methods. The Miller process. In this method, chlorine gas is bubbled through molten gold. Impurities react with the gas, turning into chlorides that rise to the surface and are skimmed off. It's quick, efficient, and produces gold that's about 99.5% pure. The Wohlwill process. This is the gold standard, literally. Gold bars are used as anodes and placed in a bath of hydrochloric acid. By passing an electric current through, pure gold atoms collect onto a thin sheet of gold at the cathode. The result? Purity of 99.99%, often called 4 nines fine. Both methods are still widely used. Some refineries combine them. First Miller for speed, then Wohlwill for absolute purity. Casting and molding, the birth of gold bars. Once refined, molten gold is carefully poured into molds. Each bar weighs anywhere from a few ounces to massive 400-ounce good delivery bars, the kind held in central bank vaults. The metal must be poured slowly and precisely. After cooling, every bar is tested in a lab for purity. If it passes, it's stamped with a serial number refinery mark weight purity level. At this stage, the gold is officially ready to enter the global market. Beyond bars, turning gold into coins. Not all gold ends up as chunky bars. A large amount is shaped into coins. For example, the US Mint creates coins by melting gold bars and mixing them with small amounts of copper and silver for durability. The alloy is then rolled into sheets, punched into blanks, and finally struck with designs using powerful presses. Each coin must meet strict standards in weight and dimensions before it can be released. Why gold still matters today? You might wonder, with all this effort, why go through such a complicated process for one shiny metal? The answer lies in trust and value. Gold has been treasured for thousands of years. From ancient Egyptian tombs to modern bank vaults, it's seen as a universal symbol of wealth. Governments still stockpile gold as a backup reserve. For example, the United States holds over 8,000 tons of it, mostly in Fort Knox and other secure depositories. Unlike paper money, gold can't be printed at will. Its scarcity makes it resistant to inflation and economic collapse. That's why, even in today's age of digital currencies, investors continue to buy and hold gold as a safety net. The future: gold versus crypto. Of course, the big question is, will gold always hold its throne? Some argue that cryptocurrencies could replace it as a store of value. But gold has two unbeatable qualities. It's tangible and finite. You can hold it, test it, and know it's real. Digital assets, on the other hand, are vulnerable to scams, hacks, and unpredictable crashes. So, while crypto might dominate headlines, gold's physical presence and long history of trust mean it's unlikely to lose its place anytime soon. And there you have it, the incredible journey of gold. From dirty rock buried deep underground to bars and coins shining with 99% purity. The next time you see a gold ring, a necklace, or even a gold coin, remember, behind that sparkle lies a story of fire, chemistry, danger, and centuries of human fascination. This was Food Factory, bringing you the untold secrets of how the world's most valuable treasures are made. If you enjoyed this video, don't forget to like, share, and subscribe, because we've got many more fascinating factory secrets coming your way. Until next time, stay curious, stay inspired.